In this video, we'll be performing classification using Rapid Miner Go. Hope you are ready with your Rapid Miner Go account. Oh, take a look at this. This is the cancer data that I was talking about earlier. The diagnosis column is our target variable. It has two values, M and B, to denote malignant and benign. I hope you know the meaning of malignant and benign. Please look it up if you do not know. In simple terms, malignant indicates the presence of cancer, while benign indicates no cancer. Let's ignore this ID field, it's just an indicator. That aside, we have 30 independent variables related to tissue measurements. You can see radius, texture, perimeter, etc. We'll need to see if a model can be built that relates these independent variables to the presence or absence of cancer. Now we have 30 continuous independent variables and a target variable of two levels. We'll now build a decision tree model, evaluate its performance and see if it can be used for predicting cancer for future values. The standard procedure is to split the data into 80% training and 20% test data. We'll build the model on the training data and test it using the test data. This is done to check how the model performs on unseen data. Since the model is built using training data, it is expected to perform better on the training data since the patterns were detected on the training data. The test data may have patterns not present in the training data. That's why a model is always evaluated on the test data. Okay, now to split the data, we'll have to ensure the split is a completely random split. It should not be that the test data contains data with very much different patterns from training data. Say suppose our data set is sorted by radius mean. I'll just do the sorting. Okay, and now 80% of 570, around 450. Now, if we take the top 450 records as training data and the rest as test data, now radius mean less than 17 only will be used in model creation. Well, the model will encounter only radius mean greater than 17 in test data. So, this will mean the model will perform very poorly on test data. And not only that, the model may misconstruct the influence of the radius on the final diagnosis. So we need to ensure a proper random split. So how do we do that? So I'll use the rand function in Excel. It generates a random number between 0 and 1. Now I sort the data set by this column. Okay, now I'll take 80%. So that is 456 rows and put it into another new Excel file and the rest into another Excel file. Okay, now we have the training and test data sets. Okay, a small way to check if your data is randomly distributed is to compare the percentage of target variable. It comes out to be 37.2%. Now I check the percentage of malignant in the training data set. So we find that it's more or less the same. So in case it was very much higher, it means most of your malignant data got into your training data set and most of the benign got into the test data set. So if so, the model you build may not capture the right patterns. Now if you remember the steps in a classification algorithm, these are the ones. So the first step, data collection, we have the data. The next one, data preparation. So as we have seen in the previous video, decision tree does not require any missing data or outlier handling or scaling or encoding categorical data. We just need the split of the data into training and test data set, which we have just done now. Now we'll choose our model to be decision tree. Now Rapid Miner provides the ability to train multiple algorithms in one go, but I will start with just decision tree for now. So let's train this model.